So here's the sand drawing robot I've currently got mocked up on the bench here. So we've got two arms here, and previously I've measured the absolute position of these arms with these slotted opto switches. So these are just a little slot, and they have an LED on one side and a receiver on the other, and when the arm passes through that slot, you get a little blip on the microcontroller, and then the microcontroller knows where that arm is in real space. This is important if you've got a weird container, a weird bed like I have here with this hexagonal one. You want to know exactly where your arms are, because you can't necessarily have your arms fully extended all the time, because you might bonk into the edge. And also you get a lot more options for drawing cool patterns if you have an absolute reference for your arms. You can do all kinds of cool spirograph patterns without absolute positioning on your arms, but if you want to draw a shape or something, then you need to know that angle information. So presently I've got this opto switch disconnected, and in place I've got this Hall effect sensor here. So a Hall effect sensor just turns magnetic field strength or magnetic flux into voltage. So it's got 3.3 volts ground and a signal line hooked up to it, and basically right now that signal line is sitting halfway between 0 and 3.3 volts, but when I get this magnet here, move it close or move it away, flip it over, move it close, move it away, then it will see a spike on a voltage. Either it'll spike towards ground or it'll spike up towards 3.3 volts. So right now I've changed the homing behavior of this arm to expect to see magnetic flux to determine its zero position. So I'm going to kick it off now, and it's going to start homing. I'm going to say that when it reaches there, that's home. Give it a little blip, and then it will go back to that point, and then it will start homing the other arm. The other arm is still using the opto switch, so I'm going to use the screwdriver here. Boop. And so now the robot understands that those two angles are its zero position, and it will start playing a, we've got a cool wobbly effect on the camera there. It'll start playing the pattern, assuming that that's 0, 0. So let me run that again. So it does a complete 360, looking for the point at which the arm, or which the magnetic flux is highest, and then it reverses back to that point and then starts homing the other arm from there. So next step is to hook a Hall effect sensor up to the other homing input and configure them both to expect to see that magnetic flux spike, and then I'll be able to get rid of these slotted opto switches and go all Hall effect. That's great, because these I've got a whole bag of them, whole bag of 10 for like $7 delivered. The SS49E focus. So yeah, after about half an hour of coding, this does what it needs to do. So I'm going to run a few more tests, validate that it still works in the actual enclosure, and yeah, should be cool. Okay, bye.